about similarity, and similar figures come from these things called dilations. So the target says I can draw and describe similar figures using dilations. The word dilate, we usually think of it as something getting bigger, like when your pupils dilate, they get bigger. In math, it could be bigger or smaller. So enlargements or reductions is kind of two different terms for larger or smaller, but we just call them dilations. So a dilation makes a figure larger or smaller, but has the, let me just change this, same shape. And maybe you've done similar figures before, but the shape is the same, it's just larger or smaller, reduced or enlarged. Whenever you make a shape bigger or smaller, there's a center to it. Sometimes the center's in the middle of the shape, sometimes it's outside the shape, but it's the point of reference for the dilation, like a vanishing point in a perspective drawing. Imagine you made a shape as small as possible to go down to a single point. That is the center of the dilation. The scale factor tells us how much it shrinks or stretches. And the scale factor is typically labeled K, but it could be any letter. So we're going to do a problem right off the bat here. It says apply the dilation D. So this is some rule to the polygon with the given vertices. That says describe the dilation. So we are going to plot these points and draw a triangle. Okay, so this part is not too hard. You got the x-axis, you got the y-axis. So the point 2, 1 would be right there. And you're going to label that x. That's this point. And then negative 1, 3. You should be able to plot these points without watching me. And then Z. And then connect the dots and you'll have a triangle. Sometimes these problems are triangles, sometimes they're quadrilaterals or octagons. I mean, not octagons. I mean pentagons or maybe even octagons. But usually they don't give you too many sides because it gets a little bit tedious if there are too many vertices. When you see this rule, that number is telling you to multiply by 2. So you multiply the x's by 2, you multiply the y's by 2. Those numbers are always the same. Because if it was a 2 and a 3, then it wouldn't be the same shape anymore. So you're just literally going to multiply every single number by 2. So this would be 4, 2, negative 2, 6, negative 4, 4. And then you're going to plot all those points, and that's the new enlarged shape. And then when you label these, you're going to put these little marks on there. So there's like the new X, the new Y, and the new Z. Those little tick marks or little apostrophes are read as prime. So you have X prime. Oh, I wrote this one wrong. This one's Y prime and Z prime. So we multiplied by 2, so all those red lengths should be double the blue lengths. We're not actually going to do distance formula to see if that's actually true. You have to just trust me. But if you did distance formula, the red lengths will all be double the blue. A couple of things that are not double and a couple of things that are. The angles are not doubled. The angles are the same. It's the same shape, it's just bigger. So the angles don't get doubled. The sides get doubled. The perimeter, which is adding the sides, gets doubled. The only other thing to talk about is the area, and you don't have to memorize this, but this area and this area are not doubled, okay? The big area is actually 4 times the little area. We're not going to worry about the rule there, but know that the areas are not doubled. the perimeter, which is adding these up, that is doubled. And that's something that you do need to know. The perimeter is doubled, the sides are doubled, the angles are equal. Those are all things you need to know. Now, if I were to draw a line connecting y to y and I keep going, I'll eventually hit the origin. You don't have to do that on your diagram. You can if you want. If I go x to x, that'll lead me to the origin. If I go z to z, that'll lead me to the origin. If I made the blue shape smaller and smaller, it would lead me to the origin. If I made it bigger and bigger, all of those triangles, if you follow where x, y, and z are going, would be going towards that origin or away from that origin. So the center is the origin, 0, 0. It's always 0, 0 on these. So even if you don't understand anything, if it asks you for the center of dilation, just write 0, 0. Now, it's possible to have a scale factor or a center that's not 0, 0, but it would involve some more complicated math than this. And every one we do on the coordinate plane is 0, 0. Okay? The scale factor is what you multiplied by. So they became bigger, so it was 2. So on this next problem, you can go ahead of me. You're going to graph all the points. You're going to do 1/3 of each one. You are going to write them down and plot them, and you're going to answer those questions. Okay? You don't have to watch me do every point. Go ahead and do it. We'll do this one a little faster. Any questions about this while I'm doing number 2? Okay. So don't just watch me. Just do it on your own. Probably go faster if you're not looking up here. I'm going to change my color to be blue. One-third is the same thing as dividing by 3. And it's not a coincidence that I gave you all numbers that are divisible by 3. If the numbers don't divide, you can use fractions or decimals, improper fractions or mixed numbers, whatever makes you happy. I know there's one problem in the homework. It doesn't ask you to graph, it just asks you to do that. And if they ask you to divide 4 by 3, just put 4/3. Okay? Then I plot those. This triangle should look tinier, and all the sides should be 1/3 the size. And again, you don't have to draw these lines, these green lines I'm about to do, but if I connected C to the new C, B to the new B, and kept going, I'd be headed towards the origin. That decimals activity was like that. So that should remind you of that. I could actually count the distance from A to C. It's 9. And the new A to C is 3. So from 9 to 3 is 1/3. So the center 0, 0, it's always 0, 0. And the scale factor is that multiplication number. Everybody happy with that? Okay, go to the next page when you're ready. Hopefully people didn't find that to be, extremely challenging. Maybe that's stuff you've already have done before. For the next part, you're going to need a ruler. And if you don't have a ruler, you could just eyeball it. Notability has a ruler. Now, if you don't see the ruler in Notability, then you got to go to this gear and find ruler and turn it on. So if it's not there, you just gotta, it's probably not hidden unless you hit it. Okay, so I have mine in the metric system. I know it's hard to tell because they don't have it marked, but 0 is right there. So the one that's not marked between the two ones is 0. So you're gonna move this with your 2 fingers, and you're gonna put 0 on A and then you're gonna put this so that it measures the distance from A to F. Can't get this perfect. You have these little sliders here, which are a little bit helpful. When you're in Notability, if you try to draw it, it will make it perfectly go against that line. So if you're like, you know, shaky, I don't know, like it clings to that, which is what you want. So you would measure from A to F, which is exactly 5 centimeters. The problem says do a scale factor of 3, so I multiply it times 3, which is 15. And then I draw to 15, and then I'm gonna label that the new F. Okay, you can use a different color if you want.
Is it A to F or is it D to F?
We're gonna do A to F, we're gonna do A to D, and then we're gonna do A to G. And then what's gonna happen here is that those lengths that you mentioned will all be triple. So I'm not doing D to F and then tripling it. A is my center. I guess I should explain this a little slower. But the center is A, so I'm expanding it away from A, and this is the method I use. So if I'm going away from A, I put the end of the ruler on A, and D, I measure how far that is, which I guess it's around 3. And if you just want to go to 9, that's fine, but I really think that's 2.9. And so this should be 3 short of 3. And like I said, if you don't do it perfect, that's okay. In inches, that's like 3 inches. So if you're doing inches, that would be like 3 inches. Now G is going to end up going into the next problem. I'll try to adjust it for next year so it doesn't go into the next problem, but I didn't mean for that to happen. The thing got shifted down a little bit. I meant for it to be higher up in the page. Okay, so AG, does that look like 5.5 to you? 5.5. Okay, so 5.5 doubled would be 11.5. Oops. No, I mean 11, not 11.5. And then you want to go 5.5 from there, which would be 16.5. And like I said, it goes into the next problem. But I don't think that should really cause anybody stress. So I didn't measure the lengths of the sides of that triangle. What I did is I went out from A by a scale factor of 3. And then I connect the dots here. And then I get this new triangle. And that new triangle is triangle DFG. I'm going to, well, I was going to color it in, but I don't know, that seems, yeah, I'll color it in, why not, while people are working. There's no really need to color it in. Something to do while people are finishing. So I just want to ask you some questions. We'll see if people are paying attention. Okay, the center of this dilation is A. Do you think that, and the multiplication was 3, do you think the sides are 3 times the size? So is this times 3 going to equal this? Length. It should be, yes. It should be. Since not too many people answered, I guess I'll measure it to prove it. So this, if I measured it, was about 2.5. And this, if I measure it, let me get to the right spot here. Well, I didn't maybe do it perfectly. 2.5. Well, 2.5 times 3 would be 7.5. Now it's about 7.5. It's a little bit over on mine, but it's supposed to be triple. Okay, just like you, I probably didn't do it perfectly, but it's supposed to be triple. Let's do this bigger one and see. Again, it's not going to be perfect because we used a ruler and we didn't use technology necessarily. This measurement is about 4.2, 4.3. And this one is 12 point, we'll call it 12.9. That would be 4.3 times 3, 12.9. So it's pretty close to being triple. So those all should be triple. What about the angles? If I were to measure the angles of these, would the angles all be triple the size? No, the angles would be identical. The angles should not change. The perimeter would be the same. What about the areas? Is the area, the amount of space in here, tripled? Would be this. What do you think? Yes or no? Area is not tripled. Okay. But the perimeters are tripled, the sides are tripled, angles are equal. Those are things you need to know. All right. Go to this problem. It says ABC is a dilation of a triangle DEF. P is the center of dilation. You can see that P is the center. The way they drew these arrows is a little bit deceiving. It makes you think the red is the original one and the black is the new one, but it's not actually the case, okay? It says this one is a dilation of that one. So this is the one that was the starting one. The name for that is the pre-image. You can write that above here. This is the pre-image, the starting one, and this is the image, the new one. Sometimes they don't use those little tick marks they use, or those little primes, they use different letters. So again, the arrows might make you think it's the black one. You might think the bigger one is always the new one. But in this case, the bigger one goes to the smaller one, and we just want to know the scale factor. So these are our two numbers. If the numbers were like 20 and 10, it would be easier than 20 and 12. What do you think I do with those two numbers? Add them, subtract them, multiply them, divide them?
Times them by a fraction.
Well, you're trying to figure out the fraction that you would multiply by. So it's like, let me ask you this. Am I trying to figure out the number I'd multiply 20 by to get 12? Or am I trying to figure out the number I'd multiply 12 by to get 20? Do you know which way I'm trying to find? 20 to 12, because that's where it's going. It's going from the black one to the red one. You know, I know yours might be black and white, but it's going from the 20 to 12. I'm trying to find that. So I'm trying to figure out what times 20 equals 12. So that's what I'm trying to find a multiplication, but I'm not going to do a multiplication. I'm going to do a division. Do you think I do 12 over 20 or 20 over 12? Everybody thinks 20 over 12? 12 over 20? Do I want the number to get bigger or smaller? Smaller. So I want the number to get smaller, so this fraction has to be less than 1, so it's 12 over 20. If you ever do it in the wrong order, you'll just try it out and it won't work, and you just do it the other order. So I'm going to simplify this fraction. These are both divisible by 4, so I get 3/5. So watch. 20 times 3/5, and the calculator has to say 12. It says 12. If I was going this way, which I'm not, it would be 5/3. This is the answer, 3/5. It's not as simple as just dividing the two numbers, because you don't need to know what order to multiply. If the thing's getting smaller, use the fraction that's less than 1. If the thing's getting bigger, use the fraction that's over 1. I just want to show you this on Schoology. I'll just do this really fast. In the Chapter 8 folder, there's the dilation animation. And you don't have to play around with this too much, but they allow you to do different scale factors. So if you look at the K, see how the K is bigger than 1? So these are all bigger than 1. And what's nice about this is that you can mess with it. So you can see how that one shape is always the same shape. It's just, different. So I can make these different. And then if I make the K equal to 1, it's right on top of the shape. Try to get 1. And then less than 1 would be going towards that point. Now, if this one has negatives, which, we're not going to do negative k's, but that would flip it to the other side, past there, along those lines. But we always do either k's less than 1 or k's greater than 1. Okay, so you can play around with that if you want. It's not really required that you mess with that, but that'll help us answer this question. If the dilated image is smaller than the original, then the scale factor is less than 1. Yeah. If you don't know the difference between a less than sign and a greater than sign, you can write it in words. You write is less than 1. If it's larger, then it's greater than 1. We don't do any negative scale factors, so we're not going to do scale factors of 1. That would keep it the same. Scale factors of 0 wouldn't, do anything except for make it, into a dot. And then negatives we don't use.